In headlights, two filaments are necessary to provide for a main and a dip beam function. These must be positioned correctly in relation to the highly polished reflector. This is called focusing and is carried out during manufacture. The main or high beam filament is positioned at the focal point of the reflector to project the maximum amount of light forward and parallel to the reflector axis. This light is then shaped by the lens, which is made up of many small glass prisms fused together. These prisms bend the light horizontally and vertically to achieve the desired pattern for road illumination. The dip or low beam is placed above and slightly to one side of the main filament. Mounting the dip filament in this position produces a beam of light that is projected downwards and towards the curbside. With this arrangement, the main filament produces the best possible light output, while the dip filament gives a downward and dispersed beam, which should not dazzle oncoming drivers. A semi-sealed beam headlight uses a replaceable bulb with a pre-focus collar. The collar locates the bulb in the headlight and also controls the correct positioning of the filaments. A sealed beam headlight has a highly polished aluminized glass reflector, which is then fused to the optically designed lens. This forms a completely sealed unit which has the filaments accurately positioned in relation to the reflector. When a filament fails in a sealed beam light, the whole unit must be replaced. Some headlight bulbs have a partial shield below the dip filament. This shield stops light from the filament striking the lower part of the reflector. The shield provides the primary shape of the dip beam. The final shaping of the beam is carried out by small cylindrical shaped prisms in the headlight lens. This provides a dipped beam that is asymmetrical. This section examines the indicator or turn signal circuit. Indicators are amber lights located on the extreme corners of the vehicle. A column-mounted switch, operated by the driver, directs a pulsing current to the indicator lights on one side of the vehicle or the other. These pulsing lights warn other road users of the vehicle's intended change of direction. Once activated, they continue until the switch is cancelled, either by the operator or by a cancelling mechanism in the switch. The cancelling mechanism operates after a turn has been completed and the steering wheel is returned to the straight ahead position. The circuit consists of the battery, fusible links and fuses, the ignition switch, the flasher unit, a 3-position switch used as the direction indicator switch, the lights at the front and rear of the vehicle, pilot lights mounted in the instrument cluster to indicate to the driver which way the switch has been operated, wiring to connect all of the components, and the ground circuit to return the electrical current to the battery. If the indicator switch is turned to indicate a right-hand turn, current from the battery flows through the fusible link to the ignition switch, where it is directed through a fuse to the flasher unit. The flasher unit uses a timing circuit to pulse the current flowing out of the flasher unit 60 to 120 times per minute. This pulsing current is directed through the indicator switch to the right-hand indicator lights at the front and rear of the vehicle, causing the lamps to flash on and off. A pilot light on the instrument cluster also pulsates. The operation of the flasher unit also produces a clicking sound to warn the driver that the indicators are in operation. When the indicator switch is returned to the off or central position, no current flows through the flasher unit, so the timer circuit is switched off. When the indicator switch is turned in the opposite direction, it directs the pulsing current to the left-hand lights at the front and rear of the vehicle, as well as the left-hand pilot light on the instrument cluster. Most modern vehicles now are equipped with hazard warning lights. This circuit is similar to the indicator lights, except that it simultaneously causes a pulsing in all exterior indicator lights and both pilot lights on the instrument panel. These can warn other road users that a hazardous condition exists, or that the vehicle is standing or parked in a dangerous position on the side of the road. This section examines parking and tail light circuits. For motor vehicles and trailers, two red tail lamps operate when the headlight switch is in the park position and the headlight position. The two lights are located close to the widest points of the vehicle, so that the vehicle width can be seen by other road users. The bulbs are connected in parallel to each other so that the failure of one filament will not cause total circuit failure. A number plate illumination lamp is usually connected in parallel to the tail lights and operates whenever the tail lights are on. The tail lights are usually incorporated in a cluster assembly at the rear of the vehicle. Government regulations control the height of the lamps and their brightness. The park lights, sometimes called clearance lamps, are located at the front of the vehicle and are used at night time when the vehicle is parked on the side of the road. They use low wattage bulbs and may have a lens or diffuser that makes the emitted light widespread. In some cases, the park lights are incorporated in the headlight assembly. The park lights operate when the light switch is moved to the first position. For safety reasons, the park and tail lights continue to operate when the light switch is moved to the headlight position. The bulbs are connected in parallel with each other. The circuit for the park and tail lights includes the battery, fusible links and fuses, park light switch, the lights at each corner of the vehicle and the number plate light, the wiring to connect the components together, and the ground circuit to complete the circuit to the battery through the vehicle frame. When the park light switch is closed, current flows from the battery through the fusible link to the park light switch, where it is fed through the fuse to the front park lights and to the rear tail and number plate lights. After passing through the filaments, the current path is completed through the frame of the vehicle to the negative battery terminal. This section examines the reversing light circuit. The reversing lights are white lights fitted to the rear of a vehicle. They provide the driver with vision behind the vehicle at night and also alert other drivers to the fact that the vehicle is to be reversed. The circuit consists of the battery, fusible links and fuses, the ignition switch, the reversing light switch on the transmission, reversing light filaments, wiring to connect the components, and the ground circuit to allow current to return to the battery through the vehicle frame. When the ignition switch is on and the vehicle is placed in reverse gear, current flows from the battery through the ignition switch to the closed reversing light switch on the transmission. Electrical current flows across the closed switch to the reversing lights and then returns to the battery by the earth return system.